In progress.
Hi, we're group number 8, and we're here to talk about the locally connected layers for robust speech and audio modules. That's our project. So to introduce, we've used a conformer model, which is a widely used speech recognition tasks. And our aim is to reduce the word error rate by introducing or replacing a few of the convolutional layers in the conformer architecture.
Hi, I'll start by introducing the original conformer architecture that was introduced by Google. This was basically created to tackle the task of automatic speech recognition, and it involves and basically integrates two very famous architectures. One is transformers, which we know are very good at capturing global context through self-attention, and CNNs, which are very effective at extracting local features. Now, the conformer model by itself has four key components that I'll just delve into very quickly. The first one is a convolutional subsampling layer, which reduces input sequence length and enables efficient processing. There's a multi-head self-attention module, which captures long-range dependencies within the data. There's feed-forward modules, which apply nonlinear transformations to enhance representational capacity. And there's a convolutional module, which focuses on local feature extraction. We have experimented with two of these, the first one being convolutional subsampling, and the final one being convolutional module, which is a part of the conformer block. There's a couple of limitations to the original conformer architecture. We know that convolutional neural networks rely on weight sharing and shared weights. And while this mechanism is very efficient, it assumes that features in all temporal regions share similar patterns. But shared weights in convolutional layers may limit adaptability to specific input regions. And while conformers perform very well in controlled environments, their robustness may decrease in noisy or reverberant conditions, which requires more testing with adversarial and non-adversarial noise.
Speaking of the work done, as previously mentioned, we tried two approaches. One was replacing the convolution module that is within the conformer block, and another was replacing the convolution subsampling that is present before the conformer block. And what we observed when replacing the convolutional module within the conformer block, and we tried with 1, 2, and 3 of these. What we observed was the word error rate was more or less similar to what we observed for the conformer model. And when we replaced the convolution subsampling, which was prior to the conformer block, the word error rate went down a little bit. And we ran these experiments for 20% of the lived speech data set. So more work needs to be done in that regard.
Moving on with the summary of our findings, the locally connected layers preserve temporal dimensions is what we found. And it does give us an increase in the computational cost, but no increase in the word error rate when it comes to changing the conformer block. Replacing convolution subsampling with a locally connected layer, though, performs better than the traditional conformer model, and it gives us a much reduced word error rate. So as the next steps, as we want to move on with the project, some of the next steps we thought of are to test with adversarial and non-adversarial noise for more robustness of our model. We also wanted to utilize the complete LibriSpeech data set to train the updated model, just rather than the 20% we were using. Experiment with different search methods like beam search. Right now, we're only using the greedy search decoder, and applying to other speech recognition tasks in the future. And as a conclusion, a key takeaway of ours was that using locally connected layers could capture local features better when used in place of convolution subsampling layers. But more experiments are required with the full data set and adding more locally connected layers in the subsampling. Thank you.